Are you done with this, or you are facing any kind of problem in this?
Yes, sir. The previous question was about weight by volume calculate.
Yeah.
So I'm not sure about what to do with density because from density we can find the volume.
Okay. See, I'm going to explain. Whenever this type of scenario you would look at, you are going to write a whole sentence about this. The way I told you, 10 gram of solute or H2SO4, you can say H2SO4 present in, since this is volume, so 100 ml of solution, right? So this is your sentence from there. And it is also given that density of solution is 1.25 gram per ml. After this, you are going to write weight by weight percent, because we need to calculate this. So weight by weight percent will be equal to weight of solute upon weight of solution into 100. Weight of solution into 100. Now from the given information, you can see this is your 10 gram of H2SO4. That means this is a weight of solute is given. Weight of solute is, easily you can look at this. Weight of solute is given, 100 is the number. Now we need to calculate weight of solution, because solution's weight is not given. Mass of solution is not given, but we have volume of the solution, and we also have density of solution. So density is equal to mass upon volume. We need to calculate mass of solution. So mass of solution will be equal to density of solution into volume of solution. Now I'm just going to put the value. Density of solution is 1.25, volume of solution is 100. So you will be getting 125 gram mass of solution. Is that clear?
Yes, sir.
Now you can see, you can easily apply, put the value. Weight of solute is, you can see 10 gram. Mass of solution is 125 gram into 100 was there. So you can easily cancel this. 25 5 ja 125, 25 4 ja 100, 5 2 ja 100, and you will get 8% weight by weight. Is that clear?
Yes, sir.
Okay, please do write it and then let me know. Then we will move to the next concentration term.
Done, sir.
Very good. Now I'm going to give you next concentration term, that is quite easy. Volume by volume percent. And you can, I think you can write a sentence about this. Can you write, can you tell me what does this means? 5% volume by volume. What does this mean?
5 ml present in of solute present in 100 ml of solution.
Very good. 5 ml of solute present in 100 ml of solution. Present in 100 ml of solution. So we can easily write a formula about this. Volume by volume percent equals to volume of solute upon volume of solution into 100. So this is the formula for volume by volume. I'm going to write all the formula here. Weight by weight percent will have a formula. Weight of solute or mass of solute upon weight of solution into 100. So this is the formula for weight by weight. Now, if you are going for weight by volume percent, then you can see weight by volume percent will be equal to weight of solute, and in denominator you can see it is volume. So volume of solution and then into 100. So these are the formula for weight by weight percent, weight by volume percent, volume by volume percent. Please do let me know so that I will change the slide.
Done, sir.
Okay. Now the next concentration term is your mole fraction. Mole fraction. And it is denoted by a term look like X, and that is known as chi. Chi. Okay. Let's say in a container we have two components. The first one is A and the second one is B, in which the number of moles of A is Na and the number of moles of B is Nb. Is that clear? This is your number of moles of A, and this is your number of moles of B. So if I'm going to write a formula about mole fraction, so mole fraction of A, that I will represent it by chi A. This represents number of mole fraction of A. That will have a formula, that is number of moles of A in numerator upon total number of moles in the container, like Na plus N. This is the formula for mole fraction. This is the formula for mole fraction. You can see it is mole fraction of A will be equal to number of moles of A upon number of moles of A plus number of moles of B. That means in denominator, in denominator we have all the moles of the container. Now I'm going to write it for you. Wait a minute. Mole fraction of B, mole fraction of B, that will be equal to chi B equals to number of moles of B upon number of moles of A plus number of moles of B. So this is the second, not second formula, it is the same formula. Only the thing changes is mole fraction of A will be equal to number of moles of A upon number of moles of A plus number of moles of B. If there will be third quantity, then you are going to write the number of moles of C here. Are you getting my point?
Yes, sir.
So this is how we deal with mole fraction. Also, mole fraction is just like if you have a bread and if you are going to divide it into this part, as you can see, this is the 1/4, this is also the 1/4, and this is the half. Or you can easily divide it into two parts. If you are going to divide this into two equal parts, that means half and half. Mole fraction is just like this. This is your half, this is your half. And if you are going to add this fraction, you will get unity. In the same way, if you are going to add the individual mole fraction, all the individual mole fraction, you will get always one. We can easily prove this. As you can see. I'm going to prove it. If I'm going to write chi A plus chi B, you know the value of chi A will be equal to number of moles of A upon number of moles of A plus number of moles of B. And the value of chi B will be equal to number of moles of B upon number of moles of A plus number of moles of B. Will be equal to, you can see the LCM of this will be Na plus Nb. And then you can easily simplify it and you will be getting 1. So if you are going to add all the individual mole fraction that is present in the container, then you will be getting a value 1 or unity. Is that clear?
Yes, sir.
One more thing is that unit of mole fraction, molic, I just wrote it wrong. Unit of mole fraction will be equal to unitless. It will be unitless. Why it is unitless? As you know that in numerator it is mole, in denominator it is mole. So mole and mole will be cancelled and the unit will be, there will be no unit. It is unitless. Is that clear?
Yes, sir, clear.
Have you written it all?
1 minute.
Just let me know if you need to slide it up, if you want to see.
Yeah, done, sir.
Now see, to calculate or to do numerical on mole fraction, you need to know what is, how we calculate number of moles. So I think you know what is the formula for number of moles. Can you tell me? Number of moles as a formula equals to number of moles equals to given mass upon molar mass. What it is? Given mass upon molar mass. So Omamuddin, can you tell me, are you comfortable in calculating molar mass? Can you calculate the molar mass?
Yes, I can.
Okay. So first of all, I'm going to give you a question to calculate moles, number of moles. Then I will give you the mole fraction. Questions on mole fraction. I'm going to give you 11.5 gram of Na plus. Calculate number of moles. Please do it. Humamuddin, are you done with this?
1 minute, sir.
Okay.
Sir, is it 0.5?
Yes, it is. Very good. Number of moles given mass upon molar mass. Given mass is 11.5 and molar mass is 23. Next question. .9 gram of H2SO4. 71 gram of Na2SO4, 0.84 gram of NaHCO3. NaHCO3. Have you got the answer of A?
First one, calculation I'm doing. So 1 minute.
Okay. You can give me answer in fraction as well.
Number of moles for H2SO4 is 0.05.
Very good. That means number of moles given mass, that is 4.9, and molar mass 98. So if you are going to remove this, it will be 10 here, and it will be 1 by 20 moles. That means 0.05. Very good. Wait a minute. What about the second one? What about the B?
1 minute, sir, doing. Sir, 0.5.
Very good. Given mass upon molar mass 142, 1 by 2, 0.5 moles. In the next one,
Uh, 0.1.
let's see. The number of moles 0.84, given mass upon molar mass 84. Molar mass of NaCO3, you have calculated 84, yes or no?
Yes, sir.
If you are going to remove this decimal, 100 will be in denominator. So it will be 1 by 100, that is 0.01 moles. Is that clear?
Yes, sir.
Okay. Now come to the main point. We are going to write 10 gram of CaCO3 present in 54 gram of H2O. Calculate mole fraction of each component. Calculate mole fraction of each component. Please do. Let me know if you are not able to solve it.
Sir,
Yes.
uh, for like after finding the number of moles, should I substitute that in the mole
Mole
fraction form?
fraction formula. Formula of the mole fraction. Yes. Can you tell me
So
the
for
number of moles that you have got of for CaCO3?
0.1 moles,
That's absolutely correct. What about for the water?
3 moles.
Very good. Now you are going to write the mole fraction of formula for CaCO3, and it will be number of moles of CaCO3 upon number of moles of CaCO3. How many component is there? Two component, CaCO3 and water. Then let me know the answer. And you need to calculate the mole fraction of H2O as well.
Okay, sir.
No.
Sir, mole fraction of CaCO3 is 0.03.
0.03. Let me check. 0.1 it will be 0.1 plus 3. So it will be 0.1 upon 3.1, right?
Yes, sir.
Now, if you are going to remove this decimal, 10 will be in denominator. If you are going to remove this decimal, 10 will be in numerator. So this will be cancelled and the answer will be 1 upon 31, right?
Yes, sir.
Now, please do check mole fraction of water.
That I got 30 by 31, which is equal to 0.9.
Okay, very good. Number of moles of water 3 upon 0.1 plus 3, that is 3 upon 3.1, that is equal to 30 by 31. If you want to cross check it, you can do that. 30 upon 31 plus 1 upon 31, that should be equal to 1. And if you are
Okay.
going to solve it, you will be getting 1. That means it's correct answer. Can I move to the next question?
Yes, sir.
So my next question is 46% weight by weight C2H5OH in aqueous solution. You know what does aqueous solution means, right?
Yes, sir.
Calculate mole fraction of each component. Calculate mole fraction of each component. Please do it. I'm waiting.
The mole fraction of C2H5OH is 0.15.
Check it again. It cannot be 0.15. See, I'm going to show you 46% weight by weight. That means 46 grams C2H5OH in 100 gram of solution. 100 gram of solution. Solution's mass is 100 gram. Solute mass is 54 gram. First of all, what is solvent? Solvent is your water. So mass of water in this will be 100 solution minus solute, that will be equal to 54 gram, right? Mass of water given 54 gram, yes or no?
Yes, sir.
Now, if you are going to calculate the moles of C2H5OH, it will be given mass that is 46 gram. Can you tell me the molar mass of C2H5OH?
46.
46. That means 1 mole it is. Now, number of moles of water is given mass 54. Molar mass is 18, so it will be 3 moles, right? Now, if you are going to calculate the mole fraction of C2H5OH, it will be equal to number of moles of C2H5OH upon number of moles of C2H5OH plus number of moles of water. This is 1 plus 1 by 4, that is equal to 1 by 5, and it will be equal to 0.2 mole fraction. Yes or no?
Yes, sir.
Now, if you are going to calculate the mole fraction of water, moles of water, that is 3. Wait a minute, I did some mistake. Here it will be 3. So the sum is basically 1 plus 3, that will be equal to 4. So it will be 0.25 mole fraction, not 0.15. Are you getting my point?
Yes, sir.
3 moles, at the place of 3 moles, I wrote firstly 5, 4, that was wrong. Now, mole fraction of water is number of moles of water upon number of moles of water plus number of moles of C2H5OH. So it will be 3 by 4, that is equal to 0.75. Where you have mistaken? Can you tell me?
So I took 100 instead of 54 grams per water.
So always be careful. This is mass of solution, not water. And so in solution, C2H5OH, solute is also there. Okay.
Okay, sir.
Okay. I'm going to give you a question on this again. 10% weight by weight, CaCO3 in aqueous solution. Calculate mole fraction of each component. Please do it. Let me know when you are done with this. Are you done with this?
Number of moles I found out. Mole fraction and then
Okay, tell me the number of moles of CaCO3.
0.1.
So you know this is aqueous solution. That means the solvent is water, right?
Yes, sir.
Can you tell me the mole fraction of this? Sorry, moles, number of moles.
5 moles. Sir.
Very good. Please put it and let me know.
Mole fraction of CaCO3 is 0.01 and water is 0.9.
0.01, you are talking about this, right?
Yes, sir.
Okay, just let me check. Mole fraction of CaCO3 will be number of moles of CaCO3, that is 0.1 upon. This is 0.1 plus 5, that will be equal to 0.1 upon 5.1. Decimal will be cancelled by decimal, so it will be 1 upon 51, right? So whenever
Yes.
you are going to calculate the mole fraction, don't do it in decimal, let it be in fraction. Have you got this answer?
Yes, I got that answer.
Okay, and then mole fraction of H2 if you are going to take, number of moles of water 5 upon 5 plus 0.1, that will be equal to 5 upon 5.1, and if you are going to remove this decimal, it will be 50 upon 51. Okay.
Yes, sir.
Okay, so this is how we calculate mole fraction. Now the next concentration term is molarity. Molarity, we denote it by capital M. First of all, I'm going to define it, and this is basically number of moles of solute present in 1 liter of solution. 1 liter of solution, or either you can define it like number of moles of solute per unit volume of solution, per unit volume of solution in liter. So we can derive a formula from here, mathematical equation. Molarity M is equal to, please do write it.
Yes.
And then normality.